Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems for actuarial exams is at smarturl.it/pass actuarial exams. Here you have links to online seminars for exams P, FM, IFM, and LTAM that I teach, and to the study manuals for exams P, FM, IFM, and LTAM that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam P, let x and y be random losses with joint density function f sub xy of xy equal to 2x for x between 0 and 1 and y between 0 and 1. An insurance policy is written to cover the loss x plus y. The policy has a deductible of 1. Calculate the expected payment under the policy. So the loss is x plus y, and the deductible is 1, which means that when x plus y is less than 1, no payment is made. The payment is only made when x plus y is greater than 1. That's the same as y greater than 1 minus x. And x and y have to be between 0 and 1, both of them, for the joint density to be positive. That's the condition given in the problem for the density to be positive. Therefore, if you look at this graph, the area marked with dotted lines between the line where y equals 1 minus x, or x plus y is equal to 1, which is that diagonal line going from y equal to 1 to x equal to 1, and the line where y equals 1 and the line where x equals 1. So that triangle indicated with the dotted lines is where the condition that x plus y is greater than 1 so that the payment is made is satisfied and the density is positive. That's the area where what we want happens. And the expected payment is the integral of the payment amount of x plus y minus 1. Because of deductible of 1, that's what is paid after the deductible is applied, over that shaded region where the payment after deductible is positive and the density is positive. And that is equal to the integral from 0 to 1. So we let y run from 0 to 1, and then from 1 minus y to 1, because x has to be greater than 1 minus 1, but less than 1, to be in the region where the density is positive and the payment is made. And the amount of payment is x plus y minus 1. The density is 2x. And in this setup, we take the integral with respect to x first, from 1 minus y to 1, and then we take the integral with respect to y. So we multiply things out, and we get the integral from 0 to 1 of the integral from 1 minus y to 1 of 2x squared plus 2xy minus 2x. We integrate this with respect to x, and we get 2/3 x cubed plus x squared y minus x squared, and we evaluate it from x equal to 1 minus y to x equal to 1. And then after we evaluate it, we'll take the integral from 0 to 1 with respect to y. And that expression that we had there, 2x cubed over 3 plus x squared y minus x squared, can be also written as x squared times 2/3 x plus y minus 1. And we evaluate it again from x equal to 1 minus y to x equal to 1. When x equals to 1, x squared is 1, 2/3 x is just 2/3. So this whole thing becomes y minus 1/3. And we subtract the value at x equal to 1 minus x, 1 minus y, I'm sorry, which is 1 minus y squared times 2/3 of 1 minus y plus y minus 1, which is minus 1 minus y. So this becomes 2/3 plus negative 1, so negative 1/3 times y minus 1. 1 minus y. Okay. Then this expression, we just multiply everything out and becomes the integral from 0 to 1 of y minus 1/3 plus 1/3 minus 3/3 y plus 3/3 y squared minus 1/3 y cubed dy. And things cancel out, and this just becomes the integral from 0 to 1 of minus y cubed over 3 plus y squared dy, which the integral of this expression is minus y to the 4th over 12 plus y cubed over 3, and we evaluate from 0 to 1. At 0, this is 0, so the only value that matters is when y equals 1, and that's negative 1/12 plus 1/3, and 1/3 minus 1/12 is 1/4, which is answer A. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the